So we know we can hear you, and I can see your screen.
Okay, let me just go to full screen. All right, first I'd like to thank the Hydrology Days Committee and especially Sarah. Sarah's done a lot of work behind the scenes to make this happen. If we were in person, she still would have put forth a Herculean lift, but I think it's been even greater to make this happen online. So want to thank her, and then want to thank everyone else who's presented. All right, so Marcy ended off with changing climate. So we know that the temperatures are getting warmer in many locations. We've got more variability in precip. We've seen a lot of research with changes in the snowpack, most of them illustrating that we're seeing decreases. Those then often give us earlier snowmelt peaks and changes in runoff. But most of the analyses has looked at the snowpack data in what I will call a bulk fashion. They look at April 1st snow water equivalent and say, how has the snowpack changed on April 1st? And we know that due to the variability, especially all the things I mentioned above, that the snowpack is going to, is not going to peak every year on April 1st. That is a surrogate. We use those data because those data are available. The NRCS, formerly SCS, has been collecting 1st of April, give or take, snow data in many locations for over 80 years. Up at Cameron Pass, one of our local mountain sites for recreation, they started collecting data in 1936. Those data are available. We can look at long-term patterns. But what does that mean if we start thinking about what happens to the snowpack? So we have used the daily SNOWTEL data from the NRCS because of their daily data. We have data from the late 70s, early 80s through present, initially snow water equivalent and precipitation, and in the last 20 to 30 years, also temperature, snow depth, and other variables. We have done an assessment, and I'll show a few of those results, looking at monthly values. We can also look at specific metrics. If we have daily snow water equivalent, we can get the date that the snowpack peaks, and we can get the amount of peak snow water equivalent. We can also get the number of days of snow on the ground. Statistically, we're using the Thiel-Sen slope rate of change, and then I'll briefly also talk about the Mann-Kendall significance test. What about if we're looking at the snow data on a daily basis? So here's the domain that we're going to focus on. This is northern Colorado. Dave Clow had a paper in Journal of Climate in 2010 and broke up the state of Colorado into a number of different areas, and he lumped some of the different stations together. So we'll have the 6 stations on the west side of the Northern Front Range. We'll call it, those are the orange stations, and then we have 7 stations on the east side. Those are the purple stations. If we look at a trend, April 1st, we can see something like this. This trend here over the last 35 or so years is significant at a p-value less than 0.1, less than 10%. But that's just April 1st. We can, as I said earlier, we can extend this back in time. If we look at May 1st, most years, April 1st is greater than May 1st, except in low snow years. Here we get a non-significant trend, although the slope is about the same. And if we look at peak values, we get another significant trend at a p-value of less than 10%. But the slopes of these are all similar. The peak trend is a little bit different. but these are still just one value in time. We use the SNOTEL data, and this is in a 2018 paper in the journal Water, and looked at some of these trends. And what we see, if we summarize the stations on the west side and east side, is we can see there's variability amongst the stations. December 1st tending to be a decrease in snow water equivalent. April 1st, most stations tending to be a decrease. But then other months like March, most stations are increasing, all the stations on the east side and at least half of them on the west side. So we see some variability. And now we're trying to think of what happens in between these. Just to dig a little further into the monthly data, we see some of these similar patterns. Here, if we look at the black diamonds, which are in the middle, we can see that precipitation, monthly precipitation over the winter is changing a little bit less, but we can see that temperature-wise, we have a fair amount of warming. In the summer, we see more warming and a greater variation. But then when we go month to month, we can see a lot of different changes. So November is warmer and drier. December is warmer and wetter. January also warmer and wetter. February, warmer and colder, etc. Right? And we see that things kind of bounce around and it's not consistent. This here is the same plot, except the circles here represent the change in the snowpack and on the first of each month, and the blue ones being an increase and the red ones being a decrease. So we can see these patterns of typically when it's warmer and drier, we have less snow, and when it's colder and wetter, we have more snow, give or take. But it's still this arbitrary time step of a month. So what we said was, let's look at the daily data. So this bottom graph here is a plot on the x-axis is day of year, starting in, sorry, there's no axes there, starting at the beginning of, I believe, September and going through into July, and we could see as it gets bluer, each of these stripes is an individual year going from 1981 through recent. And we can see there's these different years. The darker blue means more snow, so we can see near the top here, this is 2011, which was a really big snow year, and then followed by 2012, which was a dry snow year. If we take this time series and do our analyses rather than once a month, as I showed previously, or on April 1st, as I discussed at the beginning, and we look at every day, we can get these individual patterns. And the gray sections here are where these trends are not significant. Yellow is significant at a p-value less than 0.1 and red at a p-value less than 0.05. What we see is that the trends are generally decreasing, but then this change in trend, we have this increase, and then we have decrease, and we have increase. So we took this approach and we looked at all those SNOTEL stations. I'm going to start with this temperature trend. I find this fascinating. This is the daily temperature trend of there's 13 different traces in here. These gray traces represent the SNOTEL stations, and this dashed line represents the median. And what we see is that SNOTEL stations are consistent, but this thing is up and down. You know, I could take a crayon and a scrap piece of paper and draw something that's, to me, a little more sensical than what we see here, except for the fact that it is consistent. When we look at snow water equivalent trends, we see noise. This red one here is that station I showed previously. We see a lot of noise in them, but we see there are some patterns that match up, right? Some of these stations are increasing, but we also see these time periods where a lot of the stations tend to be going down. We have a change in the trend. This is now looking at the east side, those stations. These patterns amongst these stations are a little more consistent. This Willow Park, has got some negative trends throughout, but we still see similar patterns that match up with the other stations. So what we're going to do now is take these traces and try to divide them up into different patterns amongst these trends. So here I'm only taking 4 of the stations just so it's not quite as noisy. And this is actually a 7-day running average just to get rid of a little bit of the noise. And we've used these different colors in the background to denote different periods. So for example, this blue here is we have a lot of stations the stations are either increasing or there's no change. Red being, pink, excuse me, being this period where they're all decreasing, blue where they're all increasing. And we can see different time periods where we have changes and they don't always match up with months. So from from the start of the snow accumulation period into early December, we have kind of a somewhat decrease here. Then we have almost 4 months where stations either aren't changing or increasing. Then in March through middle of April, we see a decrease at most stations, and then we see an increase at pretty well all stations. This bottom is just a summary of the temperature, and this just reflects that there is consistency, but there's also a lot of oscillations. If we now take these snowpack patterns and then mesh them up with what's happening with precip, we end up seeing that there are some similar patterns here as well. Again, I'm only showing 4 of the stations to get rid of some of these noise and these traces. But what we see is, and as we expect, the precipitation patterns also then reflect what we see with the snowpack. And those continue on, and then throughout the summer, some of these stations, we see a continuing decreasing trend, but not all the stations. What's interesting here is this red one, which is Lake Irene, and this orange one, Willow Park. These are the highest 2 stations, and they generally see a decrease, and that's what we see at other stations in this domain, whereas Copeland Lake is the lowest elevation station with the least amount of snow. We're actually seeing an increase. And we do see a correlation between these trends and elevation. One more graph, and I think this one's even crazier than the previous one. One to see if there's any correlation between temperature and precip. I'm not showing temperature and snow water equivalent. And what we see is that there are changes in precip. This is going up and down, so along the x-axis, but the change in the trends in temperature are very noisy, and there's no correlation there. When we look at snow water equivalent versus precip, we can see that the lines are either going on a diagonal from bottom left to top right, or occasionally they're going in the opposite direction. There is some correlation here. We still need to go further with this analysis to see the nature of these correlations, but if we look at all the stations, we see these same patterns at all the stations where, as expected, a correlation between SWE and temperature, SWE and precipitation, no correlation with temperature. And that matches what other studies have seen, that here in Colorado, we're actually far enough away temperature-wise from having increases in temperature affect the nature of our snowpack. It's the nature of the precip that's falling. Other places like the Pacific Northwest, we see warming, and that has really changed the snowpack. We're not seeing that here. It's changes in precip patterns. So we see some interesting patterns, and we see things that are happening that don't fall along these lines of first of the month data. Right. Our next step is to dig a little bit further into this, and then we'd like to look at the entire Southern Rockies and see what things look like. And with that, I'll open it up to any questions.
Wonderful. Thanks, Stephen, and thanks for the shout out. I'm getting to be a pro at this whole online meeting thing, so you may never see me back in the office again. Just kidding. Yes, and thank you very much for putting that slide up. As some of you may know, our dear colleague and friend who kind of single-handedly managed this event for nearly 20 years recently passed away. So just a moment to acknowledge all that Dr. Ramirez did, not only for this event, but for the profession as a whole and our department here at Colorado State University. So if anyone has questions, please enter those into the chat queue or raise your hand. While we're waiting for anything to potentially come in, I would just like to add, as Stephen touched on earlier, we are producing a special issue of Colorado Water, which is the publication produced by the Colorado Water Center here at CSU. And that special issue will feature some of the work presented during the webinar, as well as a few pieces dedicated to Dr. Ramirez. So that will be coming out probably sometime in May or June, and anyone that registered for the webinar will be automatically added to our listserv, so you will be updated with that information once it's been published.
Obviously, my graphics were so breathtaking that people have no questions.
Well, actually, I did just get one. Somebody's mic is unfortunately not working, but Ethan is wondering, during what days of the year did you find a 5% and 10% significant change in SWE?
It varied from station to station. So if we look at this one here, we could see, and I'm sorry about the axes here. This is April 1st. So at this particular station, throughout the month of, pretty well throughout the month of April, give or take, is when we saw significant changes. It did vary. I don't have the other, I don't know the statistics off the top of my head from the other stations, but it's not the whole year, and it's only portions of the year, and it correlates relatively well to when those trends were the highest. When we looked at the Copeland Lake station, so let me go into this one here, most of those were actually significant. I don't know off the top of my head kind of which period, but a lot of that time period we had significant increases. But on average, it was probably, these stations have anywhere between 150 and about 250 days of snow on the ground per year. And I'd say on average, maybe a quarter to a third of those days had significant trends, either increasing or decreasing trends. The rest of them were not significant at that 10% level. And the difference between 5% and 10%, again, depended on the station.
Okay, great. That looks like it addressed Ethan's question. He says thanks. Any other questions? Let's see anything coming through. Well, big thanks to all the participants who are learning how to navigate these new waters, pun intended, as we move to online information exchange. Like I said, I'll be in touch with more information on that special issue once it's published. You can always check back at our website, hydrologydays@colostate.edu. thank you for your time today. Thank you to all of our presenters, and hopefully we will see you all next year. For now, stay healthy, stay safe, and let's stay connected, everybody. Take good care.
Right, thanks, Sarah. Thanks, everyone.
Thank you.
Thank you.
Take care, all.
All right, bye.
Bye.